Okay, so as promised, we have a quick review and then I'll demo some of the homework problems that we didn't quite get to the other night. So, in review, the degree is the highest power of the variable in a polynomial. You had that down pretty well here. The end behavior, we got to look at the degree of the polynomial as well as whether the coefficient of that largest power is positive or negative. And let's take a look at this real quick here. Like, for example, y equals x cubed. We all agree this is a third degree polynomial because the power of x, the highest power of x, the only power of x for that matter in this is 3. And then for this end behavior here, what happens is as x goes to infinity, y also goes to infinity. And as x goes to negative infinity, y goes to negative infinity, right? I just picked this function because it's simple. But what you notice is actually that if you take another third degree polynomial with a positive coefficient, for example, 2x cubed minus 6x, da 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 da, it doesn't matter what the rest of this is here. If you have a third degree polynomial with a positive coefficient, the end behavior is always going to be the same. Y still goes to positive infinity as x goes to infinity, and then y still goes to negative infinity as x goes to negative infinity. So we'll recreate this table. If we have an odd degree polynomial, say like y is equal to like something x cubed, x fifth, x to the seventh, they all work just as well. And then let's say just for example, we have a positive coefficient, like a 2, for example. As x gets large and goes to infinity, x cubed is also going to get large and go to infinity, right? So as x goes to infinity, we also have y goes to infinity, right? Because this x cubed term is gonna get very, very large. Similarly, if we have like x going to negative infinity, a negative number to an odd power is going to be negative, so y is also going to go to negative infinity. If you take something like, if you plug in just a negative number like negative 10, for example, you get y is equal to negative 2000, for example. So it's going to get very negative very quickly. So if we have an odd degree polynomial with a positive coefficient, it's going to look something like this, right? As x goes to positive infinity, y is also going to go positive infinity, and as x goes to negative infinity, y also goes to negative infinity. Similarly, actually, if we just negate this, if we have a negative coefficient, so like y is equal to something like negative 2x cubed, you end up with just the upside down of that graph. As x goes to infinity, y is going to go to negative infinity. And as x goes to negative infinity, y goes positive. If you have an even degree polynomial, on the other hand, if you have like y is equal to x squared, if you have an even degree polynomial, say like y is equal to like x squared, and a positive coefficient, then as x gets large and goes to infinity, right, this is going to get large and go to infinity, so y is going to go to infinity as well. And then similarly, as x goes to negative infinity, a negative number to an even power is going to still be positive, so it's going to look something like that. It's going to be x is going to go to infinity. Sorry, as x goes to infinity, y is also going to go to infinity. As x goes to negative infinity, y still goes to infinity. Similarly, if you just negate this, if you say like y is equal to negative x squared, for example, you just get the upside down of that. So y is going to go to negative infinity in both cases. You'll notice actually here for an odd degree function, it always goes out on the opposite side that it came in, right? So it kind of just keeps going in the same general direction, kind of. Whereas for an even degree function, it comes in and goes out on the same side, right? So let's find the roots real quick. In order to find the roots, we got to factor the function if it's not already factored, and then set each of those factors equal to 0, because remember that for the value of a function to be 0, one of the factors must be 0. So let's take a look at an example here. So let's say we have y is equal to x cubed minus 6x squared plus 9x. Let's factor it. We can take out an x, and we're left with x squared minus 6x plus 9. And then we can actually factor that one further. We can say that's equal to y is equal to x times x minus 3 quantity squared. Now, we can set each of these factors to 0. So remember that a factor of just x, this is actually the same as like x minus 0. times x minus 3 squared. So a factor of just x just means that there's a root at x equals 0. So in this case we have x equals 0, and in this case here, on this side here we have x minus 3 equals 0, and then x is equal to 3. So our roots are x equals 0 and x equals 3. And this happens to be a double root, which we'll discuss in just a minute here. So now we're going to review graphing really quickly. The first thing we're going to do is always going to be find the roots. And then after we find the roots, we're going to determine if they're single, double, triple, etc., right? And then we note that an odd number of root, for example, a single root, a triple root, a quintuple root, for example, is going to just cross over the x-axis. And we'll see that visually here in a second. An even number root, for example, a double root, a quadruple root, it's going to bounce off. So let's take a look at this kind of visually. Up here we have a single root here. It just crosses over the x-axis. So it just crosses over like this. Here, this is actually a triple root. What a triple root does is it's going to kind of flatten out a bit, and then it's going to cross over and then keep going on its way here. That works for all multiple roots, actually. And you'll learn kind of why that does that when you get to calculus as well. An even number root, on the other hand, is just going to bounce off, kind of like this here. So you can see here, this is an even a double root at x equals 0. It bounces off the x-axis. Okay, so with all that in mind, okay, let's take a look at the homework problems now. So the first one we have f of x is equal to negative x to the fourth plus x cubed plus 12x squared. We all agree this is a fourth degree polynomial because the biggest power of x is a 4. And because it's an even degree polynomial, the end behavior we know is the same on both sides. So in this case, because the coefficient is negative, we know it's going to look something like that, right? Like an m or like an upside down u or something like that. So because the coefficient is negative, as x goes to infinity, negative x to the fourth, that's also going to be it's going to go to negative infinity, right? And again, because it's an even degree function, behavior is the same on both sides. So y is also going to go to negative infinity as x goes to negative infinity. Now for the roots, we're again first going to factor it. So I'm just going to write this out again. And I can take out an x squared from all these terms. In fact, I'm going to take out a negative x squared because I want the inside here to be positive because it's easier to work with. So x squared, take out negative x squared from x cubed, you get minus x. Take out negative x squared from 12x squared, you get minus 12. And then we can actually factor the inside of here further. And if you reach back to a few lessons ago, this factors to x minus 4, and x plus 3. Okay, so now we can see the roots here. Right here we have x is equal to minus 3. Here we have x is equal to 4. And here we have x equals 0, and it's a double. So with this end behavior in mind and the roots, we can kind of sketch a graph now. So I'm going to make this, we'll call this 1, we'll call that 2. Okay, so as s goes to negative infinity, y also goes to negative infinity, so it's going to come in from this side here somehow. So our roots, let's see, we have negative 3 is the first root, so it's going to cross over something like this. And then we have, the next one is x equals 0, so it's going to have a double root there, which means it's going to bounce off, so it's going to look something like this there. And then we have x is equal to 4, and that's a single root, so it's just going to cross over. So here's x equals 4, it's just going to cross over. So the function looks something like that. And if you graph it with the graphing calculator, you'll probably get something pretty close. You can plug in a few numbers, like for example, if I plug in something like x equals 2, you can get exactly the height of this, for example. But that, again, you don't have to be exact with this. That's about what it looks like. Okay, number 5. K of x is equal to 2x cubed minus 5x squared minus 3x. Again, we all agree this is a third degree polynomial. Because it's an odd degree polynomial, we know that the end behavior is going to be the opposite on the two ends. And since we have a positive coefficient, as x goes to positive infinity, y is also going to go to infinity. So it's going to look something like that. So we know that as x goes to infinity, y also goes to infinity. X goes to negative infinity, y also goes to negative infinity. Okay, now to find the roots. I'm going to rewrite the function real quick here. I can take out an x from each of these terms, so I say that this is equal to x, take out an x from 2x cubed, I get 2x squared. Take out an x from 5x squared, I get 5x, and then minus 3. And then this actually factors a little further. We can say this is x times 2x plus 1, x minus 3. Okay, so let's set these to, let's find the zeros now as a result. Again, a factor of x just means that that's a root of x equals 0. Say 2x plus 1 is equal to 0, you get x is equal to negative 1/2. And this one here is x equals 3. Okay, so as x comes in from negative infinity, y is also coming in from negative infinity, so it's going to come in from down here in this, this third quadrant here. And the first root we see is x is equal to negative 1/2. So I'm going to set, I'll set that to 1, that's 2, 3, 1, 2, 3. Okay, so we have a root at x equals negative 1/2, and it's a single root, so it just crosses over. We have a root at x equals 0, so it crosses over again. And then our root at x is equal to 3, so something like this. So it looks something like that. And again, you can graph this with the graphing calculator or something and verify for yourself. Okay. Moving on to the next one, we have m of x is equal to x minus 2 times the quantity x plus 2 times the quantity x plus 3. So this is already factored for us, which is nice. But we can see the degree is, here's an x, here's an x, here's an x. There's gonna be an x cubed term somewhere, right? And we don't really care what else it does. All right, so we know it's a third degree polynomial, and we know the end behavior is going to be the opposite on the two ends, right? So it's going to come in the opposite side that it goes out. Now, this is a third degree polynomial, and we know that the x cubed term is actually going to be positive because this is a positive x, right? This is a positive x, and this is a positive x. So that means the x cubed term is going to be positive. So this is going to be x cubed plus something or the other. So we know that it has a positive coefficient, and it's a third degree polynomial, so it's an odd degree, so it's going to look something like that. So as x goes to infinity, y also goes to infinity. As x goes to negative infinity, we have the opposite. Y goes to negative infinity. So the roots are actually found for us, basically. We have roots at x equals 2, x equals minus 2, x equals minus 3, and they are all single roots, so that works out very nicely. So we have, let's draw our tick marks here. And so we had minus 3. Again, it's going to come in from this side as we determine with the end behavior. So it crosses over at x equals negative 3, and again at x equals negative 2, and then again at x equals 2. So something like that. Finally, we have n of x is equal to x minus 2 times x plus 2 cubed times x minus 3 times x plus 3 squared. So the degree of this one, we have 1x here, we have an x cubed plus something there, we have an x there, and we have an x squared plus something there, right? So we have 1 2, 3, 4, 5, 6, 7. So it's going to be a 7th degree polynomial. Okay, end behavior. Now, it works out nicely that all of these x's happen to be positive. So it's going to be, here's a positive x, here's a positive x cubed, positive x squared. So it's an odd degree polynomial with a positive coefficient on the dominant term. So it's going to look, again, something like that, right? So as x goes to infinity, once again, y also goes to infinity. As x goes to negative infinity, y also goes to negative infinity. Okay, now the roots, again, they basically found them for us here. So we have the first one here, we have x is equal to 2. Second term, we have x is equal to negative 2, and that's a triple root, right? We have x is equal to 3, and x is equal to negative 3, and that's a double root, right? So, draw the tick marks. Okay, so again, it's going to come in from the side here. So the first root is going to be x is equal to negative 3, and it's a double, which means it bounces off. So we'll do that. Then at negative 2, it is a triple root, which means it crosses, but it kind of tapers off a little bit, so, or it flattens out a little bit, so it does kind of like that number there. And then we have x is equal to 2, and x is equal to 3. So here's your function here. And there we go. All right. Hope that helped. Hope you have a good week. We'll see you next time.